It's Miss Sayer here in the classroom, and this week I want to share some information with you about the science of sound waves and some really important stuff about the last week of May. Something that's really important to be aware of is the upcoming grading deadline. This is a school policy, so it applies to all your classes. If you have a passing grade of A, B, C, or D, Friday, May 29th is the last day to turn in work for your semester grade. Your semester grade is going to be determined only by the work that's turned in by that date. So make sure that you're talking to all your teachers, especially if you're behind or if you've got some missing work in your classes. After May, we'll have 2 weeks of school left, and there's not going to be any graded assignments or new standards for you to do, but I'll still post stuff in Google Classroom for you to check out. I know we've had just a little bit of time to study waves, but I do want to offer you the chance to show your understanding of that topic so you can earn another standard grade. For the wave summative, you have 2 options. The standard test has 2 multiple choice questions and 4 essay questions, so it is a lot of writing, but it's not super long. You can also choose to build an instrument out of recycled materials. It might seem a little intimidating to make a musical instrument, but in fact you probably have materials for this that you can use at home without even much searching. Just to give you an idea of how simple it is to make a musical instrument, I looked around my desk and I picked up 2 materials that were right in front of me. I didn't even have to stand up. This jar and this rubber band which I stretched around it. All I had to do was put the rubber band around this jar, and I have an instrument that makes some sound. Your instrument hopefully has a lot more thought and care put into it than that, and this doesn't meet all of the requirements that are on that project list. But I just wanted to show you how easy it would be to start that kind of project, so don't be intimidated or afraid to try it out. If you're planning to do the WAVE summative assessment, no matter what, for either choice, you first have to complete the pre-work. Completing the pre-work doc shows that you've done a little bit of research and thinking about this topic and that you're ready to take the summative assessment. At the top, there's information about the different options you can choose, and there's also a rubric and some informational notes about how you'll be graded on this project. Only complete the section that applies to your summative choice. For example, if you're deciding to do the standard test, only complete this top blue section. If you've decided to build an instrument, only do option 2, and you can even erase the other box. No matter which choice you make sure that all your work is done by Friday, May 29th in order to get credit. If your pre-work is incomplete and you turn that in on Friday, you might not have enough time to finish it and turn in your project. So make sure that you get things done early and let me know right away if you have any questions or want some feedback. I hope that helps, but if you have any questions, remember you can send me an email anytime. Remember that waves transfer energy, and if you're talking about mechanical waves, they have to transfer energy through some kind of medium. Sound waves are a kind of mechanical wave, meaning that they're transferring energy throughout the medium, which for us is often air. It seems like air is empty to us because we can see straight through it, but when we learned about matter, we learned that air is actually made up of atoms. When we hear sounds, what's happening is that an object is vibrating or causing an energy disturbance, and that energy is being carried through all of the air atoms that is between the source of the sound and our ear. The volume of a sound, or how loud it is determined by the amplitude of a wave. It doesn't really matter how long the wavelengths are or the distance between the crests. What matters here is how tall the waves are. The frequency of sound waves will change the pitch of the sound, which is basically how high or low of a sound it is. So you can think of high and low notes on a piano. If a sound wave has a high frequency, that's going to be a high-pitched sound. If it has a low frequency, it's going to have a lower pitch. Notice that these 2 sound waves are pretty much the same amplitude or height. So the pitch of a note, or how high or low it is, doesn't have anything to do with the amplitude or volume. Remember that all sounds are caused by vibrations. In order for something to make a sound, it has to be able to vibrate because the vibrations are what's causing the energy to move throughout particles. Take a look at this bell as an example. This bell works because when I hit it, it's able to vibrate because it's suspended on these little strings. When I hit it, what's happening now, even though it's hard to see, is that there's tiny vibrations moving throughout this bar. But if I stop it, the sound stops. I can change the volume or the amplitude of this sound wave depending on how much force I use when I strike the bell. If I use very little force, it's going to be a quiet sound, and that would be a low amplitude. small amplitude wave. If I use more force when I hit it, now the amplitude of that sound wave is higher, so it sounds louder to my ears. One more instrument I want to show you is called a spring drum. It has an empty chamber like this, a drum head on the bottom, and a spring that hangs loose from the bottom. All you need to do to make the drum work is move the spring. The more I move the spring, the higher the amplitude is going to be because I'm using more force. More energy equals more amplitude equals higher volume. The purpose of the chamber of the drum, or the inside, is to allow sound waves to vibrate further inside of this chamber here, which makes them louder sounding to our ears. This gives them more room to vibrate, which often gives them a lower frequency. That's why big drums like bass drums tend to have a lower pitch than small drums like snare drums or bongos. Here's another example of sound waves moving through objects. As I strike these instruments going up in size, you're going to hear lower pitches because the larger an object is, the more room it has to vibrate, and so it's going to have a lower frequency. Picture a pipe organ. These have larger and smaller tubes and pipes depending on the kind of note that we want the instrument to make. This works the exact same way. Larger pipes are going to make lower pitches, smaller pipes are going to make smaller pitches. String instruments work the exact same way. The larger a string or the heavier material it's made out of, the lower pitch it's going to have. The lighter the material or the smaller the string, the higher frequency it's going to have, so we'll hear a higher pitch. Take a look at these strings here. Hopefully you can see that they're a little bit different. They're made of different materials and they have different thicknesses. This is the lightest string. It's made of a thin nylon cord. This is the heaviest string. It's made up of a metal wire. As we move up, the materials get thicker and heavier, and this makes them have different pitches. This string has the highest pitch because it's made of the lightest material. This string has the lowest pitch because it's made of a heavier material. If you look closely, you might even be able to see the string vibrating when it's plucked.